Hi guys, I'm Carolina and I work with data. Whenever I ask you guys a question, it always feels like mini US elections. So much agreement. Still, the majority of you wanted to see how to schedule jobs in Airflow. So this is exactly what we're going to do today. In this video, I'm going to show you how to set up Airflow from scratch and how to schedule a job that runs ETL process for Spotify data. If you have your own code to schedule, that's great. If you don't, feel free to follow my data engineering course for beginners, where I show you how to build a simple pipeline that uses Spotify API. This is going to be a very crude introduction just to get you started. But to be honest, this is actually the most difficult thing about Airflow. Configuring it. That's why there are quite a few tutorials out there that use Docker, for example. Docker is a technology that is supposed to make configuration easier, so many people use it with Airflow. But if you are a total beginner, you don't want to overwhelm yourself with yet another technology. So that's why I decided to create this tutorial, basing it purely on the Airflow documentation, which is hopefully going to be much more beginners friendly. All we need is a little Python and positive attitude. Yes, we are going to fix a lot of errors before we see the light of Airflow. But if there's a will, there's a way. And I know how much you want it, so let's get into it. I'm creating a fresh virtual environment using the virtual env module. Okay, so now let's just follow all the steps that are listed on Airflow's website on the Quick Start page. Firstly, we are setting the Airflow home variable to a subfolder in our home folder. This is going to be where our Airflow sits, where all the data gets saved. And now we are installing Airflow.
Uh-oh, what's this?
I don't know what's wrong, but a quick Google search suggests that we need to install Airflow with some constraints. So let's do that. So I am uninstalling Airflow and installing it with the suggested constraints.
What again?
A few modules seem to have wrong versions. For example, Airflow says that it needs a module called Future that is between versions 0.16.0 and 0.17.0, but what we've got is 0.18.2. I'm being way too avant-garde for Airflow. With things like that, sometimes you have to take a leap of faith. Okay, back to downgrading our future. Phew, looks like we're done with the error for now anyway. So now let's edit the config file in the home Airflow directory. So when you installed Airflow, the config file appeared there, and now you can access it, open it, and edit it. I'm using the command nano. It allows you to edit a text file within the command line. You can do it in your own way. That's one way I'm familiar with. But there's also Vim and Emacs, and I guess potentially you can open it with some graphical user interface, but it's just simpler to type nano. The config file will determine many important fields, but let's just have a look at the one that is concerning us at the moment. So we need to tell Airflow where to look for our code. Okay, so let's edit the location variable and let's point it to the location of our DAGs. I know you don't know what DAGs are yet. I will get to that in a second, but for now, let's just create a subfolder called DAGs in our code repo, so where we keep our code. Can we start our Airflow web server now? Yay! Now, in a separate terminal, let's open our virtual environment again, and now let's run the Airflow scheduler. If both the scheduler and the web server are running, we are all set. So now open your favorite browser, type localhost, and voila! That is Airflow UI. Cool stuff. As you can see here, there's one DAG here. It is something that I've been playing around with when I was creating this video. Let's not worry about it for now. Let's create our own DAG. Where? In the DAGs subfolder. I just wanted to show you that the Airflow is running already, but it's time to write our own DAG for the Spotify pipeline. Okay, first of all, let's clarify things. What is a DAG? In Airflow, DAG is a directed acyclic graph. So if you've studied computer science or algorithms, you know that directed acyclic graph is a representation of a series of events. It looks like that. It is directed because there are arrows. It goes from left to right or from right to left. It's acyclical because there's no coming back. There can't be any cycles. For example, you couldn't draw an arrow from 3 to 2. So each DAG represents a collection of tasks that you want to run. That means your code that you want to run, organized in a way that reflects dependencies and relationships. Each circle in a DAG, or in proper terms, each node in a DAG, represents one task or one piece of code, one function that you want to run. Simple idea. The whole DAG is defined as a Python script. Cool, so let's do it. The very first thing that we have to do is to create a Python file called Spotify DAG that will hold our DAG code. Let's place it in the newly created DAGs subfolder. First of all, we need to import some modules. Secondly, let's create a dictionary called default args. It will hold all the arguments, all the parameters that we want to pass to Airflow to configure it, parameters such as start date. By the way, use the corrected value of the start date that is on the screen rather than what is originally in the video, because the start date should be hard-coded. Other parameters are whether we want to email a group of people if our DAG fails. That's something that we might want to do, especially in an organization where people might need to be aware of what's happening with the code and whether the data is flowing or not. We can also set number of retries. So if a DAG fails, do we want to retry and rerun it again? And here we set it to 1. Next step, we define our DAG. We give it a name, for example, Spotify DAG. As you can see here, we're passing the default args dictionary that we've just defined. We give a description and schedule interval. That defines how often do we want our program to run. In our case, we want to do it daily. Now I'm defining a little helper function just to show you what will happen in a second. Okay, the next, third important part of the DAG file is defining your operators. Operators determine what actually gets done by a task. One operator equals one task in a DAG. In our case, we are using the Python operator, but if you read the docs, you'll see that there are plenty of other operators. For example, bash operator, which allows you to run a bash script. Operators are usually atomic, which means that they are a standalone piece of functionality and they don't share resources, they don't share data, arguments, variables with other operators. That means that you cannot pass the data from one operator to another. Well, you can, and Airflow has a feature for cross-communication called XCOM, but that should rather be avoided. So we are calling our task run ETL, we give it a task ID, and in the Python callable, we are passing the function that I've just created. Lastly, you might find it a little bit weird, but we define the order of execution of the tasks by simply putting their names at the bottom of the file. So here we're putting run ETL. If we had more tasks, we would use arrows to specify the direction of the flow. Okay, cool. So let's go to the web server to see what we've just done. You can see our new DAG, Spotify DAG, has just appeared on the list of DAGs. So let's open it. There we are. We are in our newly created Spotify DAG. Let's switch to the graph view. This is perhaps the most useful view, especially if you have plenty of tasks. White border around a task means it's got no status, it's never been run. There are multiple tabs here you can explore. For example, the code tab shows you the code of our DAG, the code that we've just written. When you click on the task, it gives you some options to run this individual task, but what we want to do is to run the whole DAG. So let's click on that. Okay, that was quick. Green border means we've got success, so it ran successfully. Now let's open the logs to see what happened. As you can see, our little function has executed and we've got the output. Now onto our ETL code. So previously we put the majority of our code in main. Now let's create a separate function. Let's call it run Spotify ETL, and let's put everything that was in main inside that function, and we can delete the main. Also, at the top of the file, we had some global variables, so now let's copy them and paste them inside the newly created function. By the way, we should make them lowercase now because they are not global variables anymore, but I'm just rushing to get you through this tutorial. Also, don't forget to update your token from the Spotify website because surely it's expired. Now, let's rename the file to something more sensible than main, and let's import the newly created function in our DAG file. Now let's pass that function to the Python callable instead of the dummy function that I've just created. Lastly, let's just get rid of the validation step that was checking for dates because we hadn't thought about our schedule strategy yet. Okay, and let's rerun the DAG now. Hooray! Dark green border again! Success! Let's see the logs again. As you can see, our ETL code executed. Now, that is all great, but how can we know whether the data got downloaded? Did that even work? So let's head to dbeaver to inspect our database. Awesome! As you can see, the data that we've just downloaded from Spotify got appended to the table. And as you can see, I don't listen to Arctic Monkeys anymore. So now, if the Airflow is running, the data will get automatically downloaded and saved to your database every day. We've made it! Well, almost. Let me be honest about multiple points now. 1, we've just scratched the surface of Airflow. 2, what we've done is not very proper. It's a quick and dirty example to get you started, but you probably wouldn't write such a code in a commercial environment. I strongly encourage you to learn more about Airflow on your own, reading the documentation. It should be way easier now that you've got some foundation to build on. I would strongly suggest you start with the so-called Airflow hooks. That is something that we should probably use in our ETL process if we are saving some data to a database. That's the proper way to store credentials. That's the proper way to connect to a database. And 3, there's a problem with our Spotify token, right? It expires every, 15 minutes? Obviously, if we're just gonna hard code it like we are doing it right now in the code, this is not going to work, and tomorrow our pipeline will just fail. So what needs to be done is we need to automatically download the token from Spotify and automatically pass it to the API. It's not really that hard to do, and I've seen that there are some nice tips and answers on Stack Overflow, how to solve that, how to do that, how to basically download the token automatically. I will leave it as a little challenge for you. Perhaps in the future I will create another video that goes a little bit more in depth to Airflow and shows you more features and explains everything that I didn't manage to cover today. I hope that today's video was useful because it took me so much time to make, so I hope that this is not time wasted. If you are new to this channel, please subscribe if you're interested in videos about data engineering, machine learning, and software engineering. See you next Thursday, everyone. Ciao!